As the last piece of the preliminary passive house review, we provide a very thorough set of specs for the fresher system, HRV and ERV, um, that goes along with the main report and the Windows specs that we covered in the previous videos. The reason we go above and beyond in speccing the ERV or HRV system is because that kind of fresher system is crucial in achieving high indoor air quality inside the building, as well as in managing moisture that is uh, produced inside the building. And regular HVAC contractors have the hardest time understanding the difference between this kind of fresher system and how different it is compared to a regular forced air system. Those two systems are very different. We're going to cover that in the Appendix D. But because of that challenge that many HVAC contractors have in understanding an ERV system or HRV system, we provide very detailed specs for the airflow rates of individual registers, as well as how to commission the system once it is installed. So in front of us here, we have the usual folder that we saw in the previous videos, where we have the main report that we covered in the previous video. We have the Appendix C and the specs for the Windows. And in this video, we're going to cover the part that is related instead to the ERVs and HRVs. That is Appendix D, as well as the specs 3 for the ERV or HRV system. So I'm going to open them up. And this is what you get starting off from Appendix D. Appendix D again covers the big picture, what the goals are, what the requirements are. So we're going to start off with this one before we dive into the EMU specs 03, that is for the ERV and HRV specs. We have an overview looking at goals, terminology, how to integrate that in the design, and looking at how to integrate ventilation that is typically done by individual components such as bathroom fans, kitchen exhaust, and so on and so forth. Specific specs, as well as how to commission this system. It's very easy to install this system and then not commission it or not commission it well enough so that it does not deliver the indoor air quality and moisture management that you were hoping for and that you paid for. So looking at some overview, you have a link to a free video here that you can, it's a free video we gave for Green Building Advisor years ago. It covers the main goals of this kind of system, as well as the differences between HRVs and ERVs, which ones are best for which climate and so forth. So have a look at that video if you have the time. Then some terminology here, talking about fresher system, ERV different from HRV. HRV, heat recovery ventilator, recovers sensible heat, whereas the ERV, enthalpic recovery ventilator, means that they cover heat and moisture, sometimes called energy recovery ventilator. That is an incorrect American way to use an ERV. It recovers heat and moisture. Intake, supply, extract, exhaust, that is terminology we use in the report. Design integration, some recommendation as far as where to locate the unit, set the envelope, something that is accessible. So read that. This is something that's going to be useful for the architect or designer of the building. Then integrating that with other system for their heating and cooling. That is something that is on paper possible, but in our experience it's very hard to do, so we typically recommend not trying. I'm not saying that it is impossible, just something that is hard to do, because then the contractor may end up giving priority to the airflow rates for heating and cooling, and there goes your indoor quality out the window. Bathroom fans are going to be entirely hooked up into the ERV system. No actual fans, just the ERV venting those spaces. No need to use the conventional bathroom fans. Kitchen exhaust, we recommend to have a dedicated exhaust with a mechanical damper. Clothes dryers, we recommend using a ventless condensing dryer. whole house fans are a thing of the past, hopefully, and modern ERVs and HRVs have a function called summer bypass that allows you to get the same function as the whole house fan, but no need to open the windows. You get free cooling at night with filtered fresh air. The specs, this is something that we're going to see in the next document, so I'm going to skip over that. Some indication about commissioning. And even if you're a homeowner or a builder, this is something that you want to know. Your HVAC contractor may be the best at installing and commissioning ERVs and HRVs, but it could be as well a first timer. There's nothing wrong with that. You just need to know that this kind of system need to be commissioned and needs to be commissioned at every individual interior registers. There is no such a thing as an ERV or HRV that self-commissions or self-balances. That's something that is some pretty big misunderstanding of the language. You do in the next document. We're gonna see how we spec as part of the preliminary passive house review. We make recommendations as far as where to locate individual registers in interior rooms, and we spec the supply rate or extraction rate for those individual registers, and those airflow rates need to be commissioned and delivered, and that's something that the ERV or HRV cannot control, so that's something that needs to be manually commissioned. So that's why we went the extra mile and added indication on how to commission the system. Coming to the specs, the proper, you see we called out the type of unit. Because this is my project in climate zone 7, very cold, I'm using an ERV. ERVs are the ones that cover moisture as well as heat, and they work pretty well when the climate is very dry or very humid. So we typically spec ERVs in both very cold climates as well as really humid climate. Climate zone 6 and 7 typically spec ERVs. Climate zone 1 and 2, especially South Texas, Louisiana, Florida, all that nice, very humid climate, we end up specking ERVs. Anything in between, you can get HRVs, and HRVs that cover more heat, but they do not recover moisture. That is kind of, but we would make the kind of recommendation as part of the modeling, as the outcome of the model. Part of this table we look at, in the next table we're going to see the airflow rates that we spec for design, as well as in boost mode, so that you have the option also to set the building in boost mode to get some extra ventilation if you need it. And this is a check that we do, in that if your unit, if this Comfoil blah 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 has a maximum 200 CFM cubic feet per minute capacity, you don't want to, sorry, if your boost mode rate here is 160 CFM, so 160 cubic feet per minute, you don't want to choose an ERV that at the maximum can get to 160 CFM, because it will be running at 100% capacity, so it's going to be noisy. So this is, the percentage is a check that we do on our own work to double check and see what's this spec rate compared to the maximum capacity of the unit as a total. Then here we have a list of all the individual rooms inside the building envelope, and we look at the design rates that basically dictate how much we supply to a room as opposed to how much we extract from a room. And these two needs to be, the two totals, total supply and total extract, need to be balanced, meaning the total supply equals and is the same as the total extract. We do not want to over supply or to under pressurize the building. If you supply more than you extract, you push warm, humid air into your assembly, causing moisture damage. If you depressurize the building, so if you're extracting more than you supply, you are pulling in pollution from the outside as well as particles from inside your walls. That may be particles of insulation, dust from construction, pretty nasty stuff. So we spec always the same supply as the extraction. And in fact, looking back at the previous page, the two totals, total design rate, supply 115, extract 115, they are the same because it's balanced ventilation. Same for the boost mode. See, this is where, say, I take a shower, I want the whole building to run more, so I can boost it up from 115 to 164. That is just my design rate. But again, the total supply equals the total extraction. So if you have an HVAC contractor that recommends extracting more than you supply, or vice versa, please be aware you want the two to be balanced and the same. So these are the ventilation rate that at commissioning you will want to double check and have commission to. You have the instruction in the document we just looked at. Then other indication as far as ductwork, need for insulation, silencers, frost protection, something that is climate specific. In my case, it's very cold, so I do need frost protection. And then types of filters to block off pollution from the outside. So a higher filtration rate on the air that comes in from the outside, so intake, compared to a lower filtration rate on the air that comes from inside the house into the ERV. Something that we cover in class quite a bit. Then the next couple of pages is the floor plan of each floor of the building, each floor of the condition part of the building. And you see in orange the supply registers, whereas in blue the extraction register. So we want to supply to the living room, dining room, bedroom, and we want to extract from kitchen. This is not the kitchen exhaust. Kitchen exhaust is going to be separate. This is something you want to be very clear. Even in boost mode, a kitchen exhaust register from an ERV or HRV system extracts about 50 cubic feet a minute, which is very little. A medium exhaust, kitchen exhaust, traditional kitchen exhaust is about 400. So even in boost mode, the kitchen exhaust from the register from the ERV system extracts only about 8 times less than you need to get rid of the fumes from cooking. So as we covered in the other document, you want to have the traditional exhaust with a motorized damper, and there's indication of that in this document here. Then at the next level, the floor above, this is more indication as far as where to supply to bedroom, reading room, and extracting from basically the bathroom, the laundry room, and the hot tub room. This is a clear indication. We do not provide a duct layout, but with this register location and the list, basically this table, you have a good indication as far as how to size up your ERV or HRV fresher system and how to commission it properly so it works according to the expectation for indoor air quality.